Stan Gibilisco here, proprietor and operator of amateur radio station W1 GV Whiskey 1 Good Vibrations. I'd like to provide you with a simple definition of a term that sometimes mystifies people because it's so general and seems so vague in relation to electromagnetic theory, electromagnetic fields, electromagnetic waves. What is meant by the term free space? It doesn't mean that the space doesn't cost anything. It doesn't mean necessarily that it's free of obstructions or anything like that. So what does free space actually mean? Well, free space in general is the speed at which is a medium in which the propagation speed of electromagnetic waves equals the speed of light, c, which is approximately equal to 186,282 miles per second, or 300,000. Well, actually, let's just say 300,000 kilometers per second. That is free space. Any medium for electromagnetic wave at a particular frequency is technically free space if its propagation speed is 186,282 miles per second, or I think it's a little bit under 300,000 kilometers per second, but I forget the exact figure. So, just for the sake of consistency and approximation, 186,000 miles per second. Doubtless you have heard that term as the speed of light. That's the speed of light in free space. Now, in general, free space for visible light or most electromagnetic waves is air or a vacuum. Technically, if you want to get really technical, it has to be a perfect vacuum. Air slows it down a little bit. Other media, such as plastic, glass, water for visible light, and things like that, slow the speed considerably below these values. Those things are not free space. Air is approximately the same as these speeds, propagates electromagnetic waves with just about exactly these speeds, just a tiny bit less. Now, suppose, just for an example, that you have a half-wave dipole antenna in free space, that is, air or a vacuum. How long do you want to make that dipole antenna if it's a half a wavelength from end to end? That is, lambda over 2, a half a wavelength. On 80 meters, that would be something on the order of 132 feet. Well, when you do that, you want to take into account two factors. You want to take into account the fact that the structure of the antenna itself reduces the length of the antenna. If this were a perfect dipole antenna, 1/2 wavelength in free space would be 492 feet, 492 divided by the wavelength in feet, or 150 divided by the wavelength in meters. But because of the nature of wire antennas, electromagnetic fields propagate along the wire at somewhat less than the speed in free space, even though the radio waves emanate from the antenna at the speed of light in free space, that is 186,000 miles per second or 300,000 meters per second. If you want to calculate the length of the dipole, though, for a 1/2 wavelength, you have to shorten it a little bit because, as I said, the electromagnetic waves travel a little bit more slowly along the wire than they do in free space. In fact, approximately 95% of the speed of light in free space. So the actual formulas for a 1/2 wave dipole antenna made of typical wires, say number AWG number 12, fed in the center, would be something on the order of 468 divided by the wavelength in feet. And what's 150 times 95%? I don't know exactly, but it's a little bit less than 150 meters. You can calculate it. Multiply 150 by 95%. Oh, let's just do that. 150 times 0.95 equals 142. Let's say 143, just for kicks. So we'll erase this. And 143 times the wavelength in meters. So, for 40 meters, for a wavelength of exactly 40 meters in free space, you just multiply these numbers by 143. That turns out to be about 33 feet for a dipole antenna, a 1/2 wave dipole antenna. But the waves themselves, the 1/2 wavelength in free space, is a little bit longer than that, because a wire does not propagate or transmit electromagnetic fields at quite the speed of light in free space, only about 95%. I don't know if I've made any sense here, but free space in general, with respect to electromagnetic waves, is air or a vacuum. Technically, a perfect vacuum, like the vacuum that exists between the stars and galaxies in outer space. Free space, I don't know why they call it free. I guess that's because it's unencumbered by any materials that would tend to slow down the propagation speed of electromagnetic waves. And a vacuum has the property that c, the speed of propagation, is the same regardless of frequency for electromagnetic radiation. Free space, unencumbered space, perfect space, as fast as electromagnetic waves can go that we know of so far, until they develop something like they used to have in science fiction episodes by a certain name that you all know. Star Trek. Subspace communications. Maybe someday we'll find a way to go faster. Stangibelisco. W1GV. Saying 73, which means best regards. And regardless of the medium, free space or anything else, so long, which translates in my native fist to da 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 da.